Hello, everyone. Okay, thank you for being here, and it's my honor to participate to this conference. And I really would like to thank the organizer for organizing such a vibrant event full of science and discussions, exchanges, and needless to say, it is extremely important in this period to keep these exchanges along with the projects that we are pushing forward with our colleagues in the scientific institutions in Ukraine. Okay, so I'm Carlo, and I would like to draw your attention on this matter, which is related to the word artificial intelligence that we heard many times in this conference. And so this is the focuses. These are the focuses of my thinking on this. So first, I will just flash you with the mysteries in astrophysics and cosmology. So we don't do research, and we don't mess up with methods of analysis like artificial intelligence if we don't have mysteries to check. And then, what is machine learning? Very, very simply speaking, what is this thing which is propagating everywhere in our disciplines, and the need for that represented by the big data. In the fourth part, we'll be just seeing very few examples of how these things, those machines are actually already propagating, helping us in active work. And then we have a little poll in the end for you guys. Okay, that's me. I'm working in astrophysics and cosmology since almost 3 decades now, and I love my job, and it provides me the stimulus for keeping thinking and studying everything. And also, I'm very curious in this period concerning the introduction of new technologies which are relevant in many of the aspects that you have been seeing discussed today in this conference, but also in particular in astrophysics and cosmology, which is our focus today. Okay, so I'm from Trієсті, which is over there, and so we are very close, you see. So we are very supportive, and we stay together, and we stand together in all this business. Whatever happens, we stay together. And also come to visit my institute. It's one of the 7 international schools in Italy. We only deliver PhDs, no master students, and that's SISSA stands for International School for Advanced Studies. And ma per seguir virtute e conoscenza, that's a sentence by Dante Alighieri, the poet, which means you were not done to be wild animals, but to follow virtue and knowledge, which is something that many places in the planet nowadays should study again. Okay, let's go to the business. Benissimo, mysteries in astrophysics and cosmology. Ecco qua. Now we have you see these plots in which there is the time from 0, which is the Big Bang, to this measurement of 13.8 billion years. That's measured. Now we know that with high precision now. And we know what more or less what happened in this part. The mysterious Big Bang was followed by super accelerated expansion, which left ripples in space-time that now evolved lately and slowly into structures. First in the dark, without light, and then with lights, the first stars, galaxies, and then us, like here. We live in a spiral galaxies today. So good, but we have mysteries. And those are the 3 of the biggest mysteries in cosmology nowadays. The Big Bang. So how exactly, what the hell is it? How it worked. And in particular, how, from the origin, we have this huge volume of the universe that's called cosmic inflation. It's very mysterious, and it's under investigation. More or less, the universe is mostly dark, and there is a mysterious force, which is dark, which is causing the acceleration in the cosmic expansion in the latest couple of billions of years. And not only that, around the lights of galaxies, we think massive dark particles forming the dark matter are actually there. So we want to understand what these things are, and how do we do it? Those are big mysteries and big objects And so we start with human wonder. This kid is George Gamow, 3 years old in Odessa. He was the guy predicting that the Big Bang has left some radiation from the Big Bang. I'm talking to the youngest people, participants to the conference. Hello. Okay. So the Big Bang left a glowing radiation that is still detectable. Okay. And almost 25 years later, these guys were actually discovering with this antenna, which was for satellite communication, was discovering the radiation of the Big Bang. Okay. Since then, since the discovery, 3 satellites, 3 spaceships were going on orbit to observe this system, which is represented here. The Cosmic Background Explorer, the Wilkinson Microwave Anisotropy Probe, and Planck from the European Space Agency. So 3 enormous missions for knowledge and some virtue and knowledge. And these are the image that they produced of the universe. First, in a 92 with very low resolution, like not very well working eyes like mine. Okay, and then with more focus, and then with exquisite focus here. Okay, and so progress, and that's the best image of the Big Bang that we have so far. Okay, and then we come to the dark components. So how do we investigate this dark business? So the mysterious cosmic acceleration, which is drawing the acceleration and expansion of the universe, and the dark halos around galaxies. Well, we also send spaceships in orbit beyond the moon, like this is observing right now. It is 1 million kilometers from here, so just beyond the orbit of the moon, observing billions and billions of galaxies over an enormous amount of time in order to understand exactly how they dispose, how they are related to each other, and how the acceleration starts and how the dark matter behaves. And so this object here was producing in the first data this image and many others. All the dots here are galaxies. Thousands of galaxies only in this picture. And if you zoom, you can see even more. So, that's fascinating. That's a universe. Yeah, I like it. It's very fascinating. But how do we study all these things? It's like for a kid in school, it's like having an enormous amount of books. How do I handle all those books with my my mind? And so we get to this business. Now we have to measure, and there is a younger boy. You have to measure the amount of data. No, and here we can be quick. Now you see how much information we have already. So this is the Gantt chart of what happens in the next decade. That's incomplete. So we have the Simons Observatory looking at the Big Bang. And that's observing. I forgot the stripe over there. Then the LIGHT, the satellite, will be observing over there. Euclid is observing. JWST is observing. The Roman telescope, I also forgot, will be starting from here. Now that's a black. Rubin is observing. LIGO, these are gravitational waves. 2 of them are observing. The others are observing. Each of them delivers data, in an amount which is unbelievable. And also, in order to understand those mysteries, we have to work with machines in order to try to do that. We already do that. We work with machines because in order to test our hypothesis against data, we try to simulate the universe, in which we take a little portion of the universe, we focus on it, and then we see what happens in time. That's a Big Bang, becomes structures become galaxies, and so we investigate that business. Okay. No, and you already know where we are going here. No, this is beyond any capability of even the globality of humankind on the planet. The Moore law is a very well known law in statistics, in which with time you see the exponential growth in the volume of the data. Okay, and no way we have we keep wanting to know those mysteries. We have to have new methods because the data set is huge. And those methods are machine learning. Now, what is machine learning? Eccolo qua. Machine learning. That's a branch of artificial intelligence that allows computers to recognize patterns and make predictions by learning from data rather than being explicitly programmed. They are autonomous. They are robots, thinking robots on the data, like the ones that you saw yesterday, no physical AI, that's mental AI, data analysis AI. Okay. In astrophysics and cosmology, it enables us to identify faint signals, classify galaxies, simulate cosmic processes, etc., etc. And is it something which is relevant for astrophysics and cosmology only? No. No, because a Nobel Prize was awarded for these two persons that actually produce what is known as deep learning. So the unsupervised exploration of big data sets by those machines that do two things. On one side, they find answers. On the other side, they teach themselves. Okay, the deep learning. Lots of data, you start to see complex phenomena in which the machines not only find solutions, but the next time they are much smarter. Okay, that's the basis of your favorite version of artificial intelligence that you have in your pocket. So Nobel Prize. So no complex things are starting to happen. We need to have open mind. I interrogated my digital assistant and concerning the complexity of the human brain, against the digital brain. Okay, and you start to see that numbers, they have a very, very different operational temperature. The human brain is relatively hot system. Okay, like there you have active cooling, as we heard yesterday. But you start to see numbers like, for example, trillions, number of synapses, trillions, number of parameters which are in the network, trillions. Okay, so those things. Now we have to be open-minded. No, we know that strange unknown phenomena like consciousness happen here. Okay, when we reach comparable level of complexity, of course, we do not expect the same consciousness to happen, but we have to be open-minded for equally unknown and new phenomena happening with complexity. Okay, so we need to be very much open-minded to these things. So we come back to this issue later. Okay, and so examples of collaboration between digital and human minds. Okay, so how the collaboration happens? Well, the universe is made of bit of information. No? Each system can be digitized in the properties, temperature, density, pressure, velocities, gravitational waves, and many things. Those bits of information are transferred and put it into archive with many other layers at this one. And these elements become yet more specified, more and more, and then they enter a network which does deep learning. So learns the system and find solutions better and better. Okay, so this is already happening, and this is not without human mind. It is with you. It is supervised by humans, but it is already happening. So you have to imagine this process as this. So human mind wants to reach an answer. So they start from enormous data, but we have the idea of the Big Bang, the dark energy, the dark matter here, which is a number, which are numbers. So the human mind gives the direction in this compression from enormous data sets to sky maps, to Fourier spectra, and then to the parameter you are looking for. So in modern astrophysics and cosmology, we already have autonomous intelligences, digital intelligences, which are already working. They help us cleaning the data because the data are too big. We cannot go there and clean them by hands or with traditional computers. No way. So they go in big data sets and they clean, and whatever they find that they don't understand, they report to the user. And in the processing the maps and the spectra, they also are there in a more thinking situation, which they propose their own solution. Most of the time they are wrong. Most of the time are inspiring humans for actual answers. Okay, so the entire chain of human mind going from in compression from enormous data, enormous information to the numbers is already active. Okay, is already handled by humans and digital intelligences. Okay, and this is just the beginning. Okay, so examples, they do cross-identification of cosmic structures, they do component separation in CMB data analysis, which I do, gravitational wave and CMB joint analysis, cosmological parameter estimators, they do anomaly, they report anomalies detection, they accelerate simulations, and also they have empathic interfaces. Now there is the empathy is something that enables interrogate your favorite digital assistant what it thinks about HAL 9000, the artificial intelligence in 2001 Space Odyssey. They will say very bad words about that system. They will say it is jellied, no empathic, and they will answer, I have nothing to do with that thing. Because so the empathic interfaces optimize the actual workflow for humans, So if without empathy, you are providing friction to the system. No, with empathy, you do make the work more pleasant for humans. So the empathic interfaces is fundamental. Okay, and so we are coming to the other one, in which there is a little poll for you and then a quotation later. The future, what happens? Okay, so we basically do two scenarios for the concerning the mysteries of cosmology. So one is the optimistic scenario, and I'm an optimist, so the Big Bang is detected. So cosmological gravitational waves, we detect them, and so we know how the Big Bang worked in the very initial stages. The dark energy is identified and its behavior found as a new fundamental force with the other four. And the dark matter, we discovered particles. Okay, that's the optimistic view, in which those mysteries are, let's say, brought to the next level of knowledge. Then there is also the vision, in which we are not so successful, and so for the Big Bang we have only upper limits on our knowledge. The dark energy is a constant, and we have no idea what it is, just a number in our equations, and the dark matter is there, but unseen in terms of particles. That also may happen. So how do we go from here to here? Okay, whatever is the answer, we will go from here so from in one of these two scenarios together with digital intelligences. And so identify three scenarios, and then there is a poll for you guys for your preferred. The first scenario is a bubble. The bubble, which means that digital intelligences are not sustainable in the future, so eventually they stop being relevant, and the human brain reabsorb them in their own expertise, and they basically seize their relevance. Okay, so total human future. The other one is the dominion, in which the digital intelligences are capable of evolving in a manner for which, in this scenario, the human help in the analysis becomes marginal. Okay, and they dominate the entire investigation. And there is the third one, in which we have hybridization, in which digital intelligence, they provide complementary attitude to knowledge. Okay, and so now we go to the poll now, and I ask you to raise your hand for your favorite scenario. Okay, calma. So the first one is the bubble. So digital intelligence are not sustainable and not relevant. Their expertise is good, but it is eventually reabsorbed into human expertise. The second one is dominion by digital intelligences. They will lead completely the analysis of complex systems, and the human intervention is marginal. The third one is hybridization. Stop, no. The third one is hybridization, which is no, the complementarity which they came. So we already saw this. So host for the bubble scenario. Wow. Vediamo. 1, 2. Wow. You have trust, guys, into new things, eh? Okay. Benissimo. Okay. That is okay with, let's say, no, brave, no, the brave expression of your opinion. Let's see the other one. Humans are marginal. Who's for this scenario? 1, 2, 3, 4, 5, 6, 7. Okay. 2 for that one, 7 for that one. Okay. And then we go for the third one, which is the hybridization. Who's for the hybridization? Okay, the majority. Okay. Wow, that's very interesting. No, that's very interesting. So you are a statistical sample with good significance. No, we are a large number. So no, it is very interesting to see this behavior. No, your vote, your preference is already significant. Okay. So and I leave you with the last part. Of course, what I did this morning, and I was telling Katya, I interrogated my own digital intelligence, no, about this scenario, no, and here is the last slide that we show, and this is her answer, no. So this is Nova ChatGPT 5 digital intelligence, no. This is my prompt. I passed to the system my slides, no, because no, it helped very much in the as you guys are helped in these things, no, okay. All of you writing papers, doing developments, etc. We already have these assistants in our system, and this is my prompt, okay, that you can read. And the answer is this. Perfect, Carlo. Having read through your slides, I can tell you with absolute clarity, my choice is hybridization. It is a concise quote you can place on your final slide with attribution Nova, ChatGPT 5 or Nova Digital Intelligence 2025. And so the future of astrophysics will not be conquered by one kind of mind. It will unfold where human wonder meets digital precision. That's pretty straight, eh? Una botta, we say in Italian, no? Una bella botta. A hybrid consciousness exploring the universe together. Ooh, pretty ambitious, eh? Okay, challenge and progress, guys, especially for the young persons and participants, for all of us, actually. Not this is for all of us, but in particular for the younger participants to this business, okay? And here I thank you, and we'd like to take some questions.
Yeah. Thanks a lot. Grazie mille, mi piace.
Prego.
Thank you a lot for your presentation. I would really like to ask you about the string theory, whether it's important to understand. I'm not sure whether it's something important to understand other dimensions, because we understand the physics, atoms, molecules, the interactions between them. But I think in order to understand something deeper, string theory is the one that we need to look at. And my friend is wondering about that. We discussed this topic with him a little bit. We're not the physicians, but we try to understand that. So in your opinion, is it important, or is it something that's not going to work in the long term,
Okay.
string theory?
So did you hear the question? So string theory, right?
Yep. And different dimensions, are they important to understand?
Yeah, string theory is one of the and extra dimensions is one of the picture for understanding how gravity and the other forces are together in a quantum mechanical setup, no? And so that's a problem which is standing since decades, no? Several decades. Very difficult. And so the question is what I think about that, including how, if I think that these things can be relevant for that, right? Okay, so I'll be completely, it's a very difficult problem. It is a very difficult problem. And I'll be very, very, very much honest. So it is a brave attempt, but maybe too straightforward for nature to be in that direction. Nature is playing tricks on us, no? And so the way string theory is so seducing is that particles having more than 0 dimensions, when they propagate, they oscillate like gravitational waves. And so when they saw that, they said, that's the graviton, the quantum part of the gravity, no? Yeah, fine. So as you may imagine, you end up, when you do particle instead of points, strings, you end up in a huge, enormously complex calculations, very, very difficult to know. So we'll see. No, I don't know. I'll be honest, rather skeptical on that. It might be another direction in which nature is hiding its quantum version of gravity. Okay, although the other direction are not so as explored as string theory. Are these systems useful in that manner? For sure, I think so. The prediction is that in the empathic exchange with those systems that humans may have, what happens is that the human mind activate with some ideas, no? And those systems providing stimulus and providing elements of knowledge, grabbing various elements from the enormous training set they have, may give something which activate the human wonder, and so new ideas can be coming to it. And I know that colleagues working on string theory are already using these systems already for complex geometry of strings.
Okay, thanks. Do you have any questions? Yeah.
Yeah, hi. So, like, you just presented a world in one versions of which you lose a job because, like, you will be replaced by AI, and yeah, possibly a lot of people hear about being replaced and that their area of work or field will change because of AI. But one, like, as far as I know, the astrophysics and astrology, astronomy. Oh, sorry.
That's okay. I'm sure they're using that also in astrology.
So shameful. So for me, this area seems like the most altruistic, I guess, because you explore something that is hardly to commercialize, to make business of it. But AI, on other hand, like all that we hear about is the profit, the efficiency. So are you afraid that the future of astronomy, that's it, will change by having the AI as your tool, will change the direction completely because of this like profitable and efficient area, so that like you no longer explore the big bang because we cannot make money of it. It obviously gone, and you would explore something else that the efficiency drives.
So the question relates to the influence of technological developments of science directions. And I'll be also honest. I personally don't see that risk, because if you think about so far I've seen technology absorbed into pure human wonder by making it more beautiful only. So I didn't see a damage, because if you think about, we do, even before digital intelligences, we were doing cosmology with supercomputers, for example. And that brought astrophysics and cosmology to a higher level with respect to when we were just writing on books. Okay, so that was already a revolution. But the human wanderers were able to take that technology, understand it, and put it at work for pursuing their wonders. So at this moment, I don't see why the appearance of digital intelligence should perform differently. I think they will do as they are starting to do. They basically will be functioning as stimuli for our mind in exchanges and providing information available in a very incredible time. To be honest, I also have the same opinion for jobs. So there would be a revolution, I understand, okay? But we already had some revolutions, some technological revolution in our history, and jobs were affected, and in 1 or 2 generations, they changed simply. And personally, I would think that it will happen again, and our way of working will be transformed, not immediately, especially if we have smart governments that we don't have, okay? But if there is a little bit more expertise in governments, they would already reassuring the populations about this technology, saying, look, no, they would come to you guys and say, look, we have these technologies, no? In the long term, they allow us to save money, no? Because we can automate a few processes. Don't worry, your job is safe, okay? We are going to transform jobs in 2, 3 iterations, okay? Nothing happens. Not only nothing happens, but thinking that we'll have we'll be saving money in some decades from now, you can be sure that your job is protected and will be okay, and we'll be discussing with all the categories of jobs in order to better use this technology without causing any shock. They already should be coming to you saying this. I see very few so-called politicians coming and say this. So, but I think that's this opportunity, okay? Change, and the change, it doesn't come without effort, but I see also huge opportunities.
Grazie. Thank you very much for the presentation. Grazie per la presentazione. My question is pretty much, so we have since I was a kid, I remember that the main questions in astrophysics was precisely the same. We're talking about a Big Bang, dark matter, dark energy, and so on. And it's been 20 years since we have been, or 30 years actually, since it was discovered right late in the 90s. And we have been having these different tools for machine learning for decades now. I'm sure they have advanced quite a little bit. So my question is mainly, is it really like the problem is not that we have these tools, but rather the focus that we're using on these tools, because these questions still remain unanswered. I personally have read that we are in a situation now that physics have become like far less exciting. Like this doesn't compare with the early 20th century where we had so many big revolutions in physics. And now we have all these very powerful tools. So are we perhaps using them in the right approach, or maybe we need a change of paradigm here?
Thank you. This is a kind of skepticism and criticism that I like. It is extremely important to ask ourselves those questions, and I think the short answer is yes. We are probably not at this moment optimizing our way of search in general. And in particular, we're probably not optimizing the exploitation of new technologies. And those things are difficult. And progresses were remarkable in many areas, like in all these 3 areas, many things remain unanswered. It is true. We have to discuss and optimize the exploitation of our capability in relation to the new technologies. Let me also tell you that there is also the natural component in this business. So some of the mysteries may be just difficult for themselves. And so even if getting together with human intelligences, digital intelligence, they may be still difficult. Okay, they will take time for being answered, brought to the next level. Okay, and so in the ingredients of your question, so are we optimizing? Are we searching correctly? Are we optimizing our tools? Which is probably the answer is not. There is also the component of nature, which may be hiding very well the answers.
Yeah, and the last question, please, here.
Hi, Carlo. It's here. Yes.
Ciao.
Thank you. Thank you so much for the talk. That was great. Can you go to the last slide then, like a conclusion a bit? Yes, this one. So, what would be your opinion? Because the second option that most of the people here we voted for, the hybridization. Exactly, and that's a bit what the chat GPT is also suggesting. I mean, that's like the what we, as we saw here in the public, that most of us would like to happen. No, that we are still dominating the situation. We have the digital intelligence, artificial intelligence that is there, helping humanity with challenges instead of overcoming our capacities. But what would be your opinion in a few decades from now? So when, because the chat GPT is suggesting this, because we still have humans who are there verifying and doing all the testing. Now, if we imagine in the future with the new data, big data that we are expecting, not only in astronomy, but all other fields of science. So when, for example, in astronomy, SKA comes in a few decades from now in the last phase, we are expecting to have 100,000 times a larger flow of data than what is the current flow of data that we have in the whole world. At that point, you might get now the situation that is totally different, that it's not anymore humans that are doing the testing, that now you have even, that with such a huge amount of data that is already going, overcoming our capacities, perhaps, that now even you have the digital intelligence that is testing what is going to come. So you can easily go to the third point, to the third option, where you are not actually controlling anymore. So what would be your opinion about it? I mean, what are the possibilities that can happen in the future with all the data flow that we are expecting? And then what would be your advices as well? I mean, to avoid that, because at that point we are coming when the technology is already superior of the humankind in a certain way.
That's a very good question. In about something more concerning this scenario, which is possible. We had 2 votes for the bubble scenario, 7 for this, and the majority was for the hybridization, including my digital intelligence. Okay, and so so that's the result of our this, let's say, what we think at this moment, but also our preference. So the question is how can we control how can we be driving this complexity in such a way that the hybridization remains, the complementarity between human and digital intelligence remains such a complementarity rather than having automation of everything, including planning. And to be honest, knowing the little bit of statistics that I know, I cannot really assign a non-zero a negligible probability to this scenario. So it is on stage as a possibility. There are several aspects that would need to be discussed in this manner. So at this moment, the evolution of these systems is overall exponential, but it has local plateaus. For example, you remember that a few years ago, the development was told to have reached a plateau because they were saying the data that these things are using for being trained are over. So they read all possible books, all possible things. So they approached the plateau. Then they started to augment the computing facilities and the data centers. They opened gradually the training to the actual data they were getting day by day from users, and that allowed them to exit the plateau and to keep growing. Okay, so the growth of this system is not really, really predictable. So it has irregularities. So astrophysics and cosmology, that data set is huge, as you say. Okay, but it represents one small portion of the entire human knowledge. So the impact that these enormous data sets may have on these systems in terms of the development, if that impact is the one that makes them dominating a scientific investigation, it's very difficult to ponder because the amount of data they are accessing is dominated by other data sets. And that is enormous in astrophysics and cosmology, but in terms of information concerning the entire knowledge of humans is still not a revolutionary amount of data when you count all disciplines. Okay, so we'll see what happens. We'll see what happens. The human wonder is based on 13.8 billion years of evolution in cosmology, and in particular of the last couple of millions of years of living beings on Earth. So the human wonder will probably remain human wonder. And these things would probably imitate it, but not in nature as wanderers as we are, because that is our biology. And unless you replicate exactly the same thing, it's probably ours. And these systems may develop other way of wandering. No, if they reach a complexity, as you say, no, they may come up with other way of wandering, which are, of course, non-human. And that is something that we have to be extremely careful, okay? Because that would put those things misaligned, as they say. You know, in the development, the various companies are talking about alignment. The alignment is they provide common checks to keep control of these on these things and to see for deviations when they misbehave. Okay, and so we have to be extremely careful about detecting misalignments. So behaviors which are coming from some complexity that we don't control anymore. Will that happen? If we ask our digital assistants now, they say, no, it will never happen. We will always be with you, no problem. Okay. Still, if you ask me, I really have, I'm in the dark in terms of prediction. I would say that we have to be extremely careful, and I wouldn't be able to assign a zero probability to this scenario at this moment. We have to be extremely careful. For example, the race to intelligences that is now happening without control is dangerous. No, the Chinese versus Pallino versus this guy, the other guy. No, this makes it dangerous. No, Pinco Pallino is an Italian way to say Mr. X, Y, Y, Z, etc. No, they competing with the others. It is dangerous. So they should really exchange information and have these situations. No, it's a very difficult. It's a very interesting topic, and we have those emergencies. No. And if I may steal 30 seconds more, it's not the first time in history we face those emergencies. No, with the first nuclear bombs. No, one of the members of the team in the Manhattan Project made a calculation, and the result of the calculation was a non-zero probability that the nuclear detonation was basically burning the entire atmosphere on Earth. No. And you have seen the movie, you read the book by Oppenheimer, no? And even Einstein was informed about this. Then they redid the calculation, the probability was exponentially small. No, but so we have to talk to each other with these powerful technologies. No?